Today we're going to get down and dirty with Larry, who's going to teach us all about soil. Larry, what makes soil up?
Soil is a very complex mixture. It has three basic ingredients, which we might describe as sand, silt, and clay. Now, everybody knows the size of a grain of sand. Silt, if you want to get specific, might be 1/100th as big as a grain of sand. On the other hand, the clay particles are so small that it would require a microscope to be able to look at them. So these are the three particles that constitute soil. When assembled, they form what's known as a PED, which is a PED. Now, let us also consider that soil, to my surprise, is approximately 50% air. And the air is present because of two factors. We will call it the macro and the micro. The macro orifices and holes in the soil are something that an earthworm might do. On the other hand, the micropores are just the little teeny interstices between the sand, silt, and clay.
Are there other things in soil as well?
Yes, indeed. We might speak first of the organic matter in the soil, which, as you know, is all important for a number of reasons, which I will mention later. Also, the air that's in the soil, as you know, is 80% nitrogen, but that nitrogen is not available for plant nourishment. The micropores and the macropores, as I mentioned, retain water. Water drains very easily through the macropores, such as the size of an earthworm hole, but the micropores retain a great deal of water because of the inherent surface tension of the water itself. So even though the soil might not drain at all, it still will retain water that will nourish the plant.
You often hear the term, the soil is alive. What does that refer to, Larry?
The soil is indeed alive. It is literally teeming with all sorts of living organisms. You could start with the bacteria. You could work up through the different nematodes and the different fungi that are there, and on up to, let's say, earthworms and moles that are obviously in somebody's soil. I hope it's not in mine. So let us think that the soil is an organism, that you should treat the soil like you would treat a living plant to try to nourish it and to get the best out of it.
Last year my blueberries did wonderfully well, but my carrots didn't come up at all. What's happening there?
Well, you have a problem, young lady, and I think that we should approach it in a realistic manner. Have you ever heard of pH? pH stands for 1 over the log of the H ion concentration, which is very technical. But what that boils down to is that a pH of 5 has 10 times as much acidity as a pH of 6. And now, blueberries love acid soil, so I bet you are a low pH gardener. Whereas a high pH of, let us say, the 6 to 7 range, which is more common in vegetable gardens, would help the carrots produce. A pH of 7 is neutral, meaning there is as much acid as alkalinity in that solution. Now, for soil testing, the first thing we want to know is what is a pH? And that is all important for one very good reason, that it influences how much of other soil nutrients can be absorbed by the plants. If the pH gets too low, as an example, aluminum toxicity will occur in plants. I mean, that's indeed rare, but I just mention it to show that the pH can affect the solubility and absorption of different elements in the soil.
I bought this at the local hardware store. Will this help me with my testing my soil?
Now these kits of a do-it-yourself type are not nearly as accurate as some of the more esoteric chemical firms and university extensions. These professional sites can measure very accurately the amount of potash and phosphorus in your soil, as well as some of the minor elements that we're interested in, such as calcium and magnesium and sulfur, as well as a trace element called boron, which is very important in this area. The Master Gardener's website mentions several places that you can send your samples, including the University of Massachusetts, which is where I personally send my samples.
When I'm sending my samples, Larry, do I have to be specific? Like my problem with my blueberries versus my carrots, do I need to tell them that this is what I want them to test for?
Well, I would mention my problem and trust that they are smart enough to analyze your specimens and come out with your answer to your blueberries being successful, but not the carrots. It's very important that we collect the soil specimens correctly, and this is where you will get some exercise. What you should do is take specimens from several areas where you plan to garden, and you should dig a hole and deep enough so that you can sample the top 12 inches of soil. You might do this in 3 or 4 or 5 places around your garden and mix all of this into one large container, and then take a sample of all these samples. And it would be very handy when you send your specimen away to mention what my problems are, where I live. You might also want to mention the rainfall in the area, because all of this would enter into the, basically what you're receiving is not only a chemical analysis, but a consultation is what you might do to improve your soil and what fertilizers to add, or whether you need more organic matter or whatever.
I see you've brought some samples. What's this, Larry?
This is organic matter known as compost, and it is an essential part of any good soil. This, when mixed with the other components that I can show you here, will give us what I call my garden mix, which is 1/3 compost, 1/3 topsoil, and 1/3, the final third, is sand. By mixing the 3 ingredients in this ratio, we have what to me has been a very successful start for my garden. The pH of this is just slightly on the acid side, which vegetables prefer. It's obviously very porous and will drain well. And this is in contrast to my native soil here, which has absolutely no organic matter in it. This is by analysis, and it is very low in the components that you test for: phosphorus, potash, and the minor elements. Now, organic matter in the soil can add nutrients. The nutrients vary, obviously, a great deal depending upon what sort of organic matter you have. We all know that manure is good, and interestingly enough, it's the bird manure, such as chickens, that have the highest concentration of fertilizer. But in contrast to the so-called processed fertilizers that you buy at the hardware store, the nitrogen content might be estimated at 2, whereas the nitrogen content of a processed fertilizer might be anywhere from 10 to 30. But on the other hand, this chicken for fertilizer adds organic matter, which is the important part of any organic fertilizer is you get some of the organic matter in there that can decay and add nitrogen to the soil.
So Larry, what's the difference between using organic fertilizers and using chemical fertilizers?
A great deal of difference, and what you're doing with the processed fertilizers, I call them processed fertilizers versus unprocessed. The processed fertilizers have a high concentration, and you've seen packages that might read 20, 10, 10 or something of that nature. Now that's pretty powerful stuff. And in my opinion, for what it's worth, you should only use commercial fertilizers after having a soil test, so you know exactly what to add and how much of each. For instance, if your pH is low, you need to sweeten your soil by adding lime, which is mainly calcium. If your soil is a little too alkaline, you can acidify it, although I've never heard of anyone around here having to do that. You acidify by adding pure sulfur.
Thanks, Larry, for giving us the dirt on soil. Next, we'll be visiting with Katie at Gaia's Garden.